to give you an introduction on how to work with bits and bytes in Python. Python offers great functionality for this, which is one of the reasons why we're using Python in this course. So, useful classes in Python are bytes class, int class, integer, and byte array. We're gonna look at these now, and other classes like base64, struct, and pinASCII are useful for especially binary exploitation purposes, but we're not going to be looking at these now, but later in the lecture. So, bytes in Python are essentially strings, and they offer slicing and other string methods as well. So a byte string in Python is prefixed with a B. So B, hello, is a byte string. You can see that here. If I call type on it, it tells me, okay, type is bytes. So if I slice this now, or actually if I just access one element, here the 1, so the A, I get the value of the byte at this position, which is 97. 97 is the ASCII value of lowercase a. So since these are byte strings, we can not only use ASCII characters, but every byte value. So non-printable characters in byte strings in Python are prefixed with a \x. So if I make a byte string h \x ff is hexadecimal 255, and then I access this element in the byte string, I get the value 255, which is ff in hexadecimal. So, okay, I can turn strings into bytes by using the encode method. Encode by standard uses UTF-8 encoding. So since this is all ASCII printable, the byte string is also ASCII printable. But I could also encode this string UTF-16. As you know, UTF-16, here's a byte order mark, and then it's just encoding. UTF-16, of course, has a lot of 0 bytes in it. I could also use other encodings like UTF-32. What I can also do is I can create byte objects, byte strings from hexadecimal, just by using the bytes.fromhex function. Here's hex code, and I get back a byte string. It's of course equivalent. The FF from the here is the AB. Since these hex values are not ASCII printable, they're also shown with these \x and then hexadecimal notation. The other way around, I can also take a byte string and turn it into hex by just using the .hex method. XOR of 2 strings I can do, for example, of 2 bytes, I can do, for example, like that. I just iterate over them and then take the byte value at each position, XOR the byte value at the same position in the other byte string. So XOR is this, as in most languages in Python. Okay, I want to talk about integers. That will be especially important when we come to asymmetric cryptography. What's really great in Python is that integers just transparently grow dynamically. So I can create gigantic integers like this one, for example, and then Python just accepts this as an integer. This is the number. It's really, really huge number. We don't have to worry about being under 64 bits or anything like that. Python just grows integers dynamically. It does big integer arithmetic by default, which will be very handy in the asymmetric crypto part. Now, what's the relationship between bytes and integers? Well, I can turn bytes into an integer, just like this. Byte string, that. Then I have to use the fromBytes function and tell it that this should be interpreted big endian, and then I get this integer out. Or I can say, okay, interpret it little endian, then I get this value out. You probably know this. Big endian reads from front to back, little endian reads from back to front. I can also, the other way around, turn an integer into bytes by using the toBytes function on the integer. There I specify how long the byte string should be, and again I tell him the endianness, for example little endian here. Get a byte string back. Now the first 2 bytes, when I interpret this number as bytes, is actually ASCII printable, so it shows it as IZ. But since it's a byte string, I can also use the hex function and then get it as hexadecimal notation. So this number, interpreted little endians as bytes in hexadecimal, is this. I can also get the bit length of an integer. Since integers grow dynamically in Python, I can just use the .bitlength method on the integer. A last primitive that I want to show is byte arrays. So maybe you have a byte string and you want to change it. So for example, you want to say, okay, this last byte is not FE, it's FF or 255. Byte strings are immutable in Python, so you can't just assign values. But there's another type called byte array that works exactly the same as bytes, but it's mutable, so you can just assign a byte value to a specific index. So here we say on index 1, we want the value 255, which is FF in hexadecimal. So then we have a new byte array where the last byte is set to FF. As you can see here, we used the byte string from here to initialize the byte array. Byte arrays also offer list functions, so we can, for example, also use the append function to just append a byte value to the byte array. And that's essentially everything you need to know for now.